Hi, I'm Bill Elliott. I'm a senior engineer with DIS-TRAN Steel, and I'm here today to talk about one of the components of proper load development for the design of transmission structures. One of the first things we tell our new engineers is that the transmission pole or the structure has its own coordinate system. For the case of today, let's call this the longitudinal axis, and let's call this the transverse axis. Now, whenever we get loads, sometimes we get them and they're in the structure coordinate system. Sometimes, when the wire comes off, we get loads and they're in the wire coordinate system. So I've drawn a wire coming off the structure right here. The wire has its own coordinate system. This is the longitudinal axis of the wire, and then this is the transverse axis of the wire. If we get loads that are in the wire coordinate system, we cannot immediately apply them to the structure to design the structure. We have to transpose the loads from the wire coordinate system into the structure coordinate system. The way we do that is we will draw vectors that are parallel to the axis, parallel to the transverse axis, and then we know that if this wire is coming off at a 45-degree angle, and let's just say it's a 90-degree turning pole and there's another wire over here coming off at a 45-degree angle. And just to let you know, a common mistake a lot of people make is this is a 90-degree turning pole. This is a 90-degree turning pole because this number and this number add up to 90, not because this number is 90. That's wrong. If it's a 20-degree turning pole, the wires are coming off at 10 and 10, like that. Just wanted to point that out. So we have a longitudinal component of the wire. We need to break it into structural components. If this one's 45, this angle is 45, and then we use our trigonometric functions. We get a longitudinal component of this load for the structure, and then we will get a transverse component of this load for the structure. And you don't want to forget, if they give us a longitudinal component for the wire, they'll give us a transverse component for the wire. And we also need to break that up by putting our vectors in there. This will also be 45 in this case. And then this will be another longitudinal component for the structure, and then another transverse component for the structure. So you can see the longitudinal components actually subtract from each other. The transverse components add together. Now obviously we'll be doing the same thing on this side of the pole. Very important that you remember that transverse component and that you break these up into the structure coordinate system before you start designing your structure. Thank you for visiting our blog, and stay tuned for the next DIS-TRAN Take 2.